Hello, let's continue with the first video. So last one we just talked about we have a producer which performs the write, it's here, and the consumer perform the read. Okay, so but this is like a parent is a producer and the child is a consumer, but you can also do the in the other way, correct? For example, maybe you can use this one. This is writer, correct? Child is writer, and then parent is reader. So that means the okay. Let's look at it. Should be correct. Read and write. Yes. So that means the child process is a writer, and then is a producer, and then parent process is a consumer. But it's the same, correct? That means whether who will create the pipe. Only difference is this one. So, but these two processes have a relationship, which is the parent and child, and they communicate based on a pipe. So you can find here we only have one direction, just like this one, single one, from writer to reader, writer to reader. You can define according to your preference, but you cannot do this one at the same time. So that's only just one direction. That's why we call it unidirectional. Okay. So that means this type of pipes is only existing when the parent-child relationship holds. So that means because the parent process or child process, the parent process created the pipe, and then the child process inherit the parent's resources, including the pipe. Because we mentioned the pipe is like a file, so the parent open the file, and the child process can also access that file. But if the parent process terminate, what will happen to this pipe? Of course, terminate, the file will be closed, correct? So you need to claim back, reclaim. Operating system will reclaim the resources. So this pipe is only existing when the parent is running, when the parent process is running. When it terminates, the pipe will be gone as well. Okay, does not exist. So both Unix and Windows implement the pipe, but Windows give a new name called it anonymous pipes, but the functionality is the same. Okay, just like the ordinary pipes in Unix. So let's look at the example. We just know that we know this is like a producer-consumer relationship. We don't know which one is parent, which one is child, but it's like this relationship. One produce, the other one consume, and then produce one will do the write, and will open the file based on the write. You don't need to read. And then the consumer will open the file or the pipe. We use the pipe based on the read. So let's look at the example here. So we have an example for this one. So we use the pipe to implement the producer and the consumer relationship, or that synchronization. So the first things are the same. This is the same as previous. We have this header, and then we define the buffer size. This is for the shared memory. So shared memory is for the pipe. Correct? That means maybe this is not. We can say just like a message size, and the message size we are just like we want to create a message and then save how long, how many characters, and then we define read end to be 0 and the write end to be 1. Okay, so this is basically just like we want to differentiate which one is reading the pipe, which one is write data into the pipe. So let's look at the main function. The main function, we need to look at what is the process. Is it for parent process, for producer, or for consumer? Let's look at char write message. Okay, define a write message here, and also populate the data. Correct. So this array saves the greetings, this data here, and then the read message is just like for the child process. Correct. So we can assume this is the parent process data. This is child process. We consume data and then load it into this array, and then we define 2D array, 1D array, just two elements, with 2 elements. So it's FD. FD means file descriptor. So file descriptor, because here we consider pipe, ordinary pipe as a file, and then we access it just like we access a file. We open the file, and then we read the file, we write a file. Correct? So we provide 2 file descriptors. Why 2? Just because we have one is for producer, the other one is for consumer. Correct? So that's why we have these 2. And then we will differentiate which one is for read, which one is for write. Then we know which one is for producer and which one is for consumer. And then PID underscore T means the process ID type. So it is defined in the header. Okay. And then PID. So for this PID, we also came across this type of things before. So it's like indicate a process ID. So each process has a unique ID in the operating system. In one operating system, they are unique. So we must differentiate from each other, even the parent process, child processes. Okay. And then let's continue in the next page. Create the pipe. So you can find here we create a pipe based on the pipe system call. So this is the Unix. Unix. We define a system call to create a pipe based on this method. So you provided the FD as the parameter. The reason is that because FD has both reader and writer. So you provide this one as a parameter for this one. Means you want to bind 2 file descriptors with this file, or just like one is perform reading, the other one is perform writing. Right? If this one return -1, so we have known this thing before. So return value. If it's negative unit means error. If it's 0 means correct. If it's something means some. If it's positive value means some meaningful result. Okay. So if it's negative means this is the error, and then we print f. Print f. That means we want to print the result on in a file, to a file. So standard error file, and then pipe failed. Just record this message in that error message, and then error message file, and then return 1. If return 1 means it's error. Okay, for here, for the main function. If we return 0, correct, that will be correct. Okay, return 1, that means something wrong. Okay, and the next one, that means this is for the parent process, and after that we fork a child process. So this is like when the producer is running, we create a child process for consuming. Okay? For consuming. So we use a fork. In the Unix, we use a fork system call. We mentioned this one before as well. Okay? We create a new process, and this new process will be assigned a PID as well. So we can use the PID to decide whether this is successfully created or not. We mentioned it before. If this is successfully created, it must return a 0 value. Okay? For child process, it must be 0. If it's less than 0, means something is wrong. For this one, it's less than 0. Similarly, we print the fork failed message, error message, into the standard error file, and then return 1 as well, means there's something wrong here. Otherwise, you can find here. So next thing is that we want to perform producing and consuming, right? So producing is for producer, consuming is for consumer. So we need to first differentiate which one is the producer, whether current process, current is logic is for producer, current logic is for consumer. So how to decide? Because this process is just like the CPU can run both the main function, but when you create a new process, is another function is running, so they can share these two processes. They can share the same CPU. If you create this process on this CPU one, and then because you create another process, so these two processes they can share the same CPU unit, maybe a CPU core. And then we based on the process ID to differentiate whether currently we are running the mother process or the child process, right? So that's the idea. So we check whether the process ID is larger than 0. If larger than we mentioned, if child process must return 0. If it's larger than 0, means it must be parent process. We don't need to confirm what's the ID number. As long as it's larger than 0, means this is the parent class, parent process, okay, parent process. Because you don't need to differentiate with the other things, just differentiate with the child and the parent between these two. Okay, so this process, maybe parent process has a ID maybe 100, the other one maybe 1000, but anyway it's the same, they are larger than 0. If like this one, now we are consider just dealing with the parent process. So for parent process, you need to produce and then insert. So to make sure the pipe is a file. So this is a critical resource. We say critical resource, that means it is shared critical section or critical resource, means it's shared by multiple processes. So we don't want to multiple processes access this at the same time and then cause any problem. So when we access the critical resource, we want to disable others access. That's why we close fd read end. We know read is 0 and the write is 1, right? So we have two handlers when we create the pipe. The first one is for read, the second one is for write. So producer will produce a message and then insert into the pipe. So you don't need to read now, so we will disable the reader. So close fd. So close the file descriptor, means like close the handler, the file handler, and then we will not allow the reader to read because you already closed. Okay, you close that handler. So write to the pipe. So you can find here we have this is the process. This is for the parent process, and this one is else, means it must be equal to 0 because your test less than 0 is wrong. And then this is larger than 0. This is equal to 0. So you can find the parent process and child process. We use this one is write, so we want to insert item, and this one is read. So why we can use read and write? Just because we assume we will regard the pipe as a file, so we can use common APIs for files to access this pipe. So that's why, because anyway you can think about this is just like only difference is that like this one, the memory and the disk file is saved in the disk and then loaded into memory, and then we can read and write and append the contents. But here is the same, right? We don't need to load from the disk, it's already in the memory, and then we can read and write, and then maybe close it. We don't need to save back in the disk. But if for real disk file, we need to save back. Okay? We change it and then save back to the disk to make sure it is non-volatile. Will be always there, even the top power is gone. So this is the reason. Okay? So that means we perform similar operations like the file or file process. Okay. And then let's look at when we do the write. We need to use the file handler for this write process, so the producer. So this one we just locate the location where you want to write. Maybe you will keep writing, right? So you will move that handler. Of course, you can think about maybe not just consider like that. You can think about this is just like the pipe have two ends, and then right end is like you now want to do the write operation. You need to use the right hand with write, and left hand maybe for read, or vice versa. Right? So this one is just like perform the write, and then you open the file based on the write privilege. Okay, and then you populated the data is the write message, which has been defined in the beginning here. Okay, and then next one is the string length. That means the length of the message, and then +1. Okay, why we want to +1? Just because of this message is a string, and then we must add the \0 indicate the end of the string. So that's why usually the length will be one more than the number of characters in the string. So after we finish the writing, we have done all the things we need to do for the producer. We need to close the writing handler, correct? Write handler. So that's the same thing, correct? So this is disable reading, and then write the data, and then close the writer handler. So similarly, for example, if it's not larger than 0, PID must be equal to 0, that's the child process. Now we need to disable writer, and then read, and then close, correct? So same pattern. Close means we disable the writer, and then read. So read message, read into this one how much use buffer size. So the buffer size will be shared, okay? So the same contents. Okay, we define the 25. Okay, and then we use the reader, okay? Reader handler. So that's why it's defined in the FD, read end. So it's already attached to the pipe. So the pipe has one for read handler, the other one for write handler. So we already finished the write handler here. So now do the read handler here. After that, we print the results out. Okay, read what string, and then on the screen, print this one on the screen, and then close the read end of the pipe. So this is the similar like previous. We close the read end. Okay. So based on this one is 0. Okay? FD0 is for that file descriptor, so for the reader. And if all of them can be finished, and then we can return 0. So you can find this one is keep running. Okay? We have this if we don't have this one, we can keep running. Of course, this one will be just which one will be. You can find this one can only run one. Okay? So if we can run here is a producer message and save into the piper. And next time maybe when we do that running, it will run the child process, and then it will print the results from the pipe. Okay? Read from the pipe and then print out. So that means you can test this one. Okay, test this one in a Linux. Unix environment. You already have that virtual machine, correct? You can test there. Okay, so this is for Unix, and then in fact for Windows we said we call the name the anonymous pipes. In fact, the only difference for here is just the name, correct? System core definition will be different. So other things, this we use a fork, but here we use a create process, and then write a file similar like a previous, correct? And then read the file. So that means you can take a look for this one as well. Just like so, that means the only difference is for this one. We just concentrate more on the Unix one because our project is also that one, and the Unix you may have less experience. Okay, so we focus on that one. So let's look at next one. So this is for the ordinary pipe. So the problem is that this is only allow parent-child relationship, but sometimes we don't have this relationship, but we still have the communication requirements. They don't have a relationship between two processes, but we want to perform communication. So using this one cannot, because this one is must has a required parent-child relationship. So that's why we create another one called lambda pipes. It is more powerful than the ordinary pipe. Why is it more powerful? So this one does not require parent-child relationship. So there's no parent-child relationship is necessary. And the other one is this is bidirectional. Preferred one is unidirectional. And the third one is that for the preferred one I mentioned, the ordinary pipe will only exist when the parent process is active. When it is terminated, the pipe will also gone because it is created by the parent process. But for here is different. So even the some process has been gone, the pipe still can be there. And also we can have several processes. For the previous one, you can find one is read, write, the other one is read. Read and write. For here, we can allow multiple writer, okay, and multiple reader. So that means you don't need to use just one pair, one to the other one. And this one also provided on both Unix and Windows systems. Okay, you can take a look. In our book, I believe they also only mentioned roughly. So for this lambda pipe, okay, we do have, or we don't have an example for this one. It's only example for the Windows example we just mentioned. Okay, so that means for here we just skip the details. Okay, and then let's do the quiz. So the first one, an or a. Okay, is what allows several unrelated processes to use the pipe for communication. First one, so which one allows unrelated processes? The most important keyword is this one. Okay? So lambda pipe, anonymous pipe. That's Windows name for the lambda pipe. For the ordinary pipe, anonymous means no name. Okay? LIFO, last in, first out. What is that? Okay? And the ordinary pipe. So should be these are the equal. Okay? So should be, if this is correct, this is correct. So cannot be both true. This is not related. So it's a lambda pipe. We mentioned just now. Okay? It's strong. It's more powerful. Which of the following statement is true? A. Lambda pipes do not allow bidirectional communication. We just mentioned it allowed. No. Only the parent and child process can use the lambda pipes for communication. We don't have a data requirement. No. Reading and writing to ordinary pipes on both Unix and Windows systems can be performed like ordinary file I/O. Yeah, we do like that. That's correct. So lambda pipes can only be used by communicating processes on the same machine. That's not correct. We didn't mention about this one because lambda pipes, they can be used in the different nodes, different machines. It's ordinary pipe. Why is ordinary pipe can only do that? Ordinary pipe is a parent-child relationship. You cannot put two parent and child, separate them from each other. So they must be in the same machine, because the parent process is running on one CPU core, and then it will create another child process, still run the same core. So it's within. They share the CPU core, CPU running unit, but cannot ship it to the another one. okay, to another running unit, another computer. Okay, so named pipes continue to exist in the system after creating process has terminated. We mentioned it before, right? If it's ordinary pipe, cannot, they must be gone after the creating process terminated. But named process, it allows, so it is true, okay? Okay, let's continue for the last section, which is about communication in CS systems. That means there's a client, there are a server, and there are multiple clients. Okay, multiple clients. Okay, multiple clients, and so on. So how can we have the communication between them? Okay, so this is the topic for here. I believe for some other courses you may have learned before, because for example, even like a database, kind of we mentioned about this CS. This is reasonable because the unit database is located in a server, and then we have a client to access the data set. So we need to communicate. How to communicate via network, can't? So this is we will consider this communication. Why we consider this one? Because you can think about there are some processes here who is running. So we set it as host, and then running some server. There are also some processes which are listening to the request. So you send a request to that process. The process will perform the operation, and after that result, return the result to the host process, client process. So this is the logic there. It's still between two processes. Only difference now is just like this is a big computer system. It's distributed, not in the same location, not in one computer system, right? Not in one computer hardware, okay? One piece of hardware. They are in different computer nodes within the distributed system. So basically, we concentrate on the first one, the sockets, and then we don't want to talk about the RPC. Make it even harder for you. So sockets, as long as you understand this one, should be enough, because the sockets are more commonly used in our related courses subjects. Okay, let's look at what is the socket-based communication for CS system. So first one is the definition. What is a socket? So if I have finished my database course, you should be already know this one, okay? Socket is just like a combination of IP address and the port number. We must know which IP to identify the computer. We must use the port number to differentiate multiple services provided by the same IP, okay? Same IP. So this is the idea, IP and the port. Use IP to locate the computer hardware server, and use port to locate the functionalities, to locate the process who will handle your request. Okay, just like you have an apartment, and then there's a lot of mailboxes. So you must find out which department, which apartment, and then which unit number, okay? Which then you can communicate with the person. Okay, apartment, unit. Okay, same. So this is a number included at the start of message packet. So we said here we use the message passing, right? You will have different method to perform this network communication. We didn't cover that course in our program, but it's important. So basically we have two different ones, and we'll explain a little bit later. That means how can we wrap a message, okay, using different format. How can we establish connection? So this is a number included at the start of message packet. We send a message packet. So maybe data is a bit bigger, so we may send the packet along the link, correct? The transmission link. So maybe someone will go further faster, even you even label it. They don't arrive in the same order, but when they reached in the termination end, they will be sorted, correct? They will sorted accordingly. So because different routing will have different delays, and then they will not follow the same order. So packet is like this way. So packet, you will know, like you send a email, send a mail, and then you need to have the address, destination address, and the contents, correct? Like these things. So that's the header of the message. Okay. For example, like this one, the socket, this one, the previous one is this is IP address, correct? So we use 32, correct? 32. So because this one is from 0 to 255, 25 means 8 bits, correct? 8 bits, 8 by 4. So we have 32. So now we use IPv6, correct? We have more. So in the past we only have this. You can think the address, correct? So all of them is 2 to the power 32. So identify this number for computers. So now we need to have more. That's why we use IPv6. And the second one is 1625. This is for the port number. So to port number is just like to differentiate which surface, find the process who will listen to this request, correct? Or you can think about it just like identify a process. Maybe it's on the server, maybe it's on the clients, but I just want to differentiate different processes. So to port 1625 on host, so now host means your client, and then communication consists between a pair of sockets. So that means in the C part you need to have the IP and the port in the socket. In the S part, server part, you also need to have this socket. So that's why we communicate based on this pair of sockets. Okay, with the sockets you can only reach a process now. Which computer, which process, okay? Then you will know. And then we have a tradition. All ports below 1024 are well known. That means they are reserved. We can, if we create our own socket, we cannot use that one again. This one is for standard services. Okay, in the book we mentioned about, for example, like 80 is for HTTP, and 27 is for FTP, right? And then for some others. Let's look at special IP address. For example, you want to test your maybe CS based application, client and server based application. You don't have to use really two computers. You can test locally. So you use a simulation. So the IP address for the computer itself is 127.0.0.1. Okay. Period. Maybe use period better. Period 0 period. Okay. Anyway, and this is loopback. That means the computer itself. So that means you based on the same IP address, you still can replace. You don't need to have a network. You need to rent maybe create a website. You can test locally. Okay, just based on this one, and then you just don't use the same port number, and then you can differentiate. Maybe one is 1000, the other one is 2000. So this one is client, this one is server. Done. Correct? Because you have IP, you have port. They represent two different things. That's already enough. And all connections consist of a unique pair of sockets. That's no problem. For example, this example, host means a client, and the server socket. This is IP, this is IP, and then for this one is the port number, this one is port number. So you know this 80 is for HTTP. For example, use browser. Okay? For this surface, it's below 124. Okay? 1024. So this is reserved. Okay. Let's look at example. So we look at Java. Java in fact have a socket class. That's why we use Java for this example. So let's look at the first some knowledge is about the socket types. So this one in fact is based on the network protocol. So we have TCP and the UDP, different protocols. So first one is connection oriented TCP. The other one is connectionless. That means there's no need to establish a connection, but the first one need to have a connection. First establish connection and then send a message, send a packet. We also have a multicast socket. That means one to many. So you send an announcement, just like I'm doing an announcement, everybody will receive my announcement. Okay? This is like a multicast. So in the conference, okay? Data can be sent to multiple recipients. Okay. Consider this date server in Java. So what is this one? For example, the client want to get the time information based on the server's provided service. That means retrieve the time information from the server. This one uses the TCP sockets. So that means based on connection. It will request current date and time from the server. Let's look at this one. So let's look at this example. So for this one, it's based on socket. That means for the client want to retrieve the current date and the time from the server. So this one is about the server, data server. Okay. So it's about the server one, and the next one is about the client. So two classes. Okay. So let's look at the first one, the server. So basically, the logic for the server is just like we want to retrieve the time and then write into the socket. And for reader is like we read from the socket. Okay. So this is the idea. Let's look at. So for this class, we define one function called the public static void main function. Okay, this is the input, and then we try and catch. That means this is the exception. So inside of this one, we will create. You can find it with the system call. We create a server socket. So for the here, we create a socket. So that means this is the common one for client socket. So this one is the server socket. So while with 0601713, this is just a number. Want to establish the connection. Okay, just request a connection. So let's look at the next. Now listen for the connections. Okay, so I mean we create an object. Okay, create an object to connect with a client. So we listen to the client's request in this while loop. While true, that means keep doing this one. Okay, will not finish. Okay, as long as your server is running, this server is running, this function is running, or process is running, and then socket client equal to sock.accept. So that means you can find we now define. That means we already create an object. So now we accept. Socket has a function called accept. That means this is just like we accept the request. Okay, request from the client, and then we do what you can find here. We new print writer. So now we just want to write the time. Write the time into the socket. So write this. We knew a data, new output string. That means for this client socket it has output address, just like a stream. You can think about it as a space to save some data. So this is like a barrel or like a container. It can hold some data, and then we write. So it's pout.println. So it's this one cut. So new object, and then it's println. So line by line, using the Java utility API, and the date. Change this one to be string. So that means we write this date into line, okay, into line by line. Print a line, okay, to a string. Change this one to be a string. This one initially is just maybe they use millisecond, okay? Millisecond from a year to now. What's how many milliseconds? And then you can translate it into the current date. So after that, that means it has been write the data into this object, okay, ready to be accessed. So it's like you have a server here, and then you create a socket, you write the data into it, and then the client can read from here. So this is the idea. Okay, this one close. Okay, this one has been written into that one. So now this socket can be, yeah. That means for this one, if we found for example the request and then accept it, and then we have finished the writing the data. So this is already finished. So that means we can close this one. Close this one. That means it's ready for the client to read. Okay, this is here. The client, data client. So you can find the difference is you can find it here. The IP address is just itself. So within the same computer, right? So establish request the connection, and then for here is in. The prefix is out, right? Output string. This one is the input string, because this is where read data. And then get its input string. Okay, similarly, just define this is like a file, right? Like a file, and then the address, starting address, and then after that you will read. Just create a buffer reader bin. This is just temporarily save the data. Okay, the bin. So new buffer reader. Buffer reader temporarily save this one. Okay, this is just extends the reader text from a character input string. Okay, and then after that, just you read your new input string reader from the in. Okay, from this sock. Okay, from this sock. So you establish you know it's that one, and then that sock. That means you establish connection. You have reached that data, the socket. So now you can read out the data into the buffer bin, and after that you just print it out, bin written line by line, output it, right? Okay, and then also close the socket connection. So basic idea is just like you use a socket. This is already defined class in the Java socket. So you can call its related functions to implement. So you can find it's a very short program for this communication. Okay, let's continue. For the last one is the quiz. Imagine that a host with the IP address, this one, wishes to download a file. So this is the IP address. Download a file from the web server. Okay, we don't know whether it's based on FTP or HTTP. FTP is file transfer protocol. HTTP is a hypertext transmission protocol. So for this one, this is client, this is server. Select a valid socket pair for a connection between this pair of hosts. So we know this is a server, so this is a server, this is a client, and the only difference is seems like this port number. So this one seems we don't know what it works, but it seems like HTTP is better. So this one at least it's possible. But how about this one? Which one is correct? So because this one is host IP, so it must use this is a process running on the host, so it's not like standard services. So we cannot use we must use larger than this 1024. So only this one is correct. Okay, let's continue for the next one. When communicating with the sockets, a client process initiates a request for connection and is assigned a port by the host computer. Which of the following would be a valid port assignment for the host computer? Same rule. This one. A socket is identified by an IP address concatenated with a port number. That's true. Okay, that's all for this chapter 3. And then we already finished this chapter, so you are ready to finish all the contents for the PA1. And and PA2 is for the next chapter 4. So we'll continue next for chapter 4. So to prepare you well for the PA2 next project. Okay, I will release this one right away.